Hi, fourth grade. This is Mrs. Simone. I hope you and your family are doing well. Today we're going to review Module 3, Lesson 4. Alright, the icons we'll be using is Read, Draw, Write, Learning Target, Personal Whiteboard, Problem Set, Fluency, and you'll be doing this work individually. Alright, we're going to try to finish this under 60 minutes. Okay, the target for today is I can interpret and represent patterns when multiplying by 10, 100, and 1,000 in arrays and numerically. Alright, and at the time, go ahead and get your paper and pencil out. Alright, so here we go. We're going to begin our fluency. I'm going to go ahead and get the color. Let's do green. So, 14 tens, if we write this in standard form, that will be 140. Alright. Alright, so 14 hundredths. That will give us 1,400. Alright, moving on to the next one. Okay. Alright, and here we go. So we have 14,000. So that will give us 14 thousandths. So that one was simple. Moving on. Alright, now we have 18 tens, so that will be 180. Alright, moving on. Alright, and we got the 180. Now our next problem. So we have 28 tens, so that will be 280. Alright, now let's move on. Okay, so 28 hundredths, that will be 2,800. Okay, moving on. Alright, so 28 thousandths, that would be 28 thousandths. So this one's pretty simple there. Alright, moving on. Alright, so now we're going to count by threes to 30. So here we go. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Alright, now count by 3 tens. When I raise my hand, stop counting. So the only difference with this one, we're just going to add the tens in there. So it's going to go probably a little bit slower because we don't really say 3 tens, 6 tens when we're talking. Unless we're in a math class. Alright, so here we go. 3 tens, 6 tens, 9 tens, 12 tens, 15 tens, 18 tens, 21 tens, 24 tens, and stop. Alright, so let's move on. So find the area and perimeter. We have 2 centimeters over here for our width, and for our length we have 9 centimeters. And our equation down here is length times width, so we're going to find the area. So let's go ahead and plug in our numbers. So our length we said was 9. I'm not going to rewrite the equation down here because it's already down there. I'm just going to reference it. So 9 centimeters times 2 centimeters equals 18 centimeters squared. And bada boom, bada bang, we are done. Alright, let's move on. Use the formula for perimeter to solve. So same number, same width and length. Now we're going to use our formula down here, which is 2 times, and then open parenthesis, length plus width equals perimeter. So let's go ahead and just plug it in. So we're going to put our 2 times, and then our length is 9 centimeters. Alright, plus our 3 centimeters. Alright, close parenthesis, equals perimeter. Alright, so let's go ahead and we're going to bring down the 2 times. And then we're going to add 9 plus 3, which is 12 centimeters, equals perimeter. So 2 times 12 is 24. So we have 24 centimeters equals our perimeter. So that means all this outer edge out here, that is our perimeter. Okay, moving on. So on your personal whiteboard, write the multiplication sentence to find area. So we're going to write it since it's not listed anywhere. So you should have length times width equals area. So here we go. We have 7 centimeters times 7 centimeters equals area. So 7 times 7 is 49 centimeters squared equals area. Okay, so we're done. Let's keep it moving. Use the formula for perimeter to solve. So our formula is down here, so we'll just go ahead and plug in. So let's change this color. I'm getting tired of the green. So let's do, I really like this blue right here. So 2 times, all right, and then let's plug in 7 centimeters plus 7 centimeters equals perimeter. All right, so 2 times, and then 7 plus 7 is 14, so 14 centimeters equals perimeter. All right, so 2 times 14 is 28, so 28 centimeters is our perimeter. I believe 49 was our area, so everything within here was 49 centimeters squared, and then the perimeter, the outer edge of this rectangle here, was 28 centimeters. Alright, so it says this is a square, so that's letting us know that all sides will be equal. Say the length of each side. So 4 centimeters, 4 centimeters, 4 centimeters, 4 centimeters. Alright, so let's move on. So on your personal whiteboard, write a multiplication sentence to find the area. So we already have one down here, length times width, so let's go ahead and plug it in. We know all our sides are equal, so I know that it's going to be 4. So, very quickly, what is 4 times 4? Yep, hopefully you got it. It's 16. So we're going to put 16, I'm going to do square centimeters just to change it up a little bit. Alright, equals area. Alright, and we're done. Alright, so now we're going to find the perimeter. So the area was 16 in here, so now we're going to find the perimeter, just the outer edges here. So, here we go. Using our formula that's given to us down there, we're just going to simply plug in these numbers. Wow. Wow. I'm just, you know, this is really bothering my OCD. It really is. Like, but you know, can't help it. So gotta deal with it. So 4 centimeters plus 4 centimeters is 8. Why am I putting this parenthesis here? Okay. So 8 centimeters equals perimeter. So 2 times 8 is 16. So 16 centimeters squared. Not squared. Stop that nonsense. Okay, equals perimeter. So all the outer edges of this square here is 16 centimeters. All right, let's move on. So this is a square. Say the length of each side. So 5 centimeters, 5 centimeters, 5 centimeters, 5 centimeters. All right, I already have my highlighter out, so I can just go ahead and go to the next slide. So it wants us to find the area. So let's go ahead and do 5 centimeters times 5 centimeters equals area. All right, so 5 times 5 is 25. And then centimeters squared equals area. All right, and we are done. So let's keep it moving. Next. So we just found out the area for this. It was 25 centimeters squared. Now we're going to find the perimeter. So use the formula for perimeter to solve. And this is what Eureka Math really wants us to use. So I know when we did a lesson in the beginning together, I listed them all, but not this time, because this is what Eureka wants. Getting you ready for that middle school math. Okay. Alright, so 2 times, and then 5 plus 5 is 10 centimeters equals perimeter. So 2 times 10 is 20. So 20 centimeters equals perimeter. Alright, and moving on. The area is 10 squared centimeters. So I'm going to put it in here, 10 squared centimeters. Wow. Alright, on your whiteboards, write a division equation to find the width. So that would be, because we have the area and we have the length, so we would do area divided by length equals width. Alright, and now I'm going to go ahead and just go to the pen, since I don't have that much space. And change up the color here. So here we go. I'm going to put 10 squared centimeters divided by 2 centimeters, equals the width. Alright, so 10 divided by 2 is 5. So 5 centimeters equals the width. If we were going to solve and check, you could do 2 times 5 and equal 10. So we got it correct. Okay, moving on. The area is 55 square centimeters, so I'm going to go ahead and switch back over to my highlighter. 55, and I'll do centimeters squared. Write a division equation to find the width, so it'll be the same one. We have our area, we have our length. What we don't have is our width. So that is our unknown. So let me go ahead and switch back over to the pen. So we have 55 centimeters squared divided by, and I was supposed to put length. What am I thinking? Come on, Julie, let's get it together. Okay, so there we go. Alright, so now our length, which is 5 centimeters, Alright, so 55 centimeters squared divided by 5 centimeters equals the width, and that will give us 11 centimeters equals width. Bada boom, bada bang, we're done. Alright, the area is 35 square centimeters. So 35 centimeters squared. Make that look more like a C. Alright, and we're going to write our division sentence. We have our area. We have our length. And we're solving for our width. So let's go ahead and switch back to the pen. And let's do red. Okay, so 35 centimeters squared divided by 5 centimeters equals W. Okay, so 35 divided by 5 is 7. So 7 centimeters equals the width. Okay, moving on. Application problem. So here we go. Samantha received an allowance of $3 every week. By babysitting, she earned an additional $30 every week. How much money did Samantha have in 4 weeks, combining her allowance and her babysitting? So here we go. I have enough space, so I'm going to switch back to my highlighter here. And there's, first let's start with cubes. So C-U-B-E-S. Okay, so right here we could do this one or two ways. We could do this, it said for every week, and she has 4 weeks. Why I'm trying to jump ahead of myself, let's follow cubes. Let me follow cubes. So cubes, circle all important numbers. So that's what we're doing. All important numbers that are $3 or $30 in the 4 weeks. Now underline the question, and the question is, how much money did Samantha have in 4 weeks, combining her allowance and her babysitting? Box in any math word, so combining would be a math word to box in. That lets us know if we're going to add or subtract. Evaluate what we're going to do. Well, we know is every week, and how many weeks do we have? We have 4 weeks, so we can either do 3 4 times and 30 4 times, or what I'm going to do is just add the 3 plus the 30 and then do it 4 times so I can just save some time. And then we're going to solve and check at the end. So I'm going to switch back to my highlighter. So let's do 3 plus 30, and let's see, that gives us, because we're talking about dollars here, even though I didn't put it here, just trying to save space. So $33. So let's see here. Let's go ahead and do our tape diagram. And I'm going to switch back to the pen over here so I can have enough space after I do my lines. So that should be 4 boxes. Yep, 4. So switch back to my pen. Alright, so $33. And you know what? I'm not going to put a dollar sign each time. Okay, so we're done with that. Now, we got our tape diagram, and now what we need to do is just either add it 4 times or we can multiply it 4 times. All in favor of multiplying? Yes, let's do it. So, 33 times 4 Okay, so $33. And this represents the 4 weeks over here. Okay. Alright, and I'm going to solve in a different color. So let's do... Nah, too generic. Let's do green. That's probably look nice. I don't know. So 4 times 3 is 12. Carry the 1. 4 times 3 is 12 plus 1. 13. So she made a total of $132. Really? Okay. So, if I were to write my answer statement, I will write it down here. I'll let you do that on your own. So you would say Samantha made $132 for, how can I say this and sum it up? So, combining her allowance and her babysitting. So, she earned $132 for babysitting and her allowance. So, that's what you can put. Alright. Not make it too complicated. Oh, if we go back, because for cubes, you got to solve and check. So, if you were going to solve and check here, what you could do is you could solve it the other way too, to see by doing 3 4 times and 34 times and then combining it and doing that. Or let's see, I think that's just the best way. Just solve it the other method and see if you get it right. Okay. Or you could divide to 132 divided by 3 and then you should get 4. So you could do that as well. So I just wanted at least explain it, walk with you on what you can do to solve and check it. So we're now at the concept development. We're going to be using place value here. So here we go. If you need time to draw your place value chart, go ahead and do that. So it says, how many do you see? So we have 1, 2, 3, 3 ones. So let's keep it moving. Alright, so we have, how many groups of 3 do you see? Just one group of 3. And they circled the one group of 3. Okay? So, it says, suppose I wanted to multiply 3 ones by 10 instead. How would I do that? So, if I have 3 ones, so basically I would have this 3 times 110. What would that equal, right? So I would just drag this over here, show my multiplication on this line, what I'm doing here, and then draw my 3 discs. So now my new number would be 3 tens, which is 30, right? And the way I know it's 30, I could just count by tens. So 10, 20, 30. Alright, and we're good. So if I wanted to multiply that by 10, so we had 3 tens, right? And it's saying what happened if we wanted to multiply this by 10? What could we do? Or what will we come up with? So I always like to just, write the multiplication sentence so that you can just see another way that this can be expressed. Alright, so that will give me 300 if I multiply it by 10. Because every time you move one place value to the left, it's going to increase by 10. So now I have 300, which in standard form you still pronounce it the same way. Oops. Come on now. This is why I usually write in standard form, because spelling things out just looks a hot mess. Alright, let's move on. So there we go. So if we had 3 ones and times it by 10, times it by 10. So right here, another way that we can look at this is you could do 3 times 100. That's another way that we could express this. But the way we did 3 times 10 times 10. And we know that 10 times 10 is 100. And then that leaves us with 3 times 100. So it's all the same. Okay? Just a different way to express it. Alright, so look at my equation. I started with 3 ones. What did I multiply 3 ones by to get 3 hundreds? And I just went over that. So, look at my equation. I started with 3 ones. What did I multiply 3 ones by to get 3 hundreds? And I just went over that. So, let's keep it moving. So now we have a new equation here. Work with a partner. I will be your partner. So how can you solve 3 times 1,000? So here we go. Let's go ahead and switch up this color here and to the highlighter. Oh, we gave us a different color. So 1, 2, and 3. All right, we're going to multiply it by 1,000. So how many place values would that be if each one is 10? So if this is 10, and this is another 10, and now we have another 10. So kind of already let us know it's going to be over here. So I would do this. 2 times 1,000. And I'm showing a multiplication so you can see what I'm doing here. And that's what you need to do too in your work. Show that multiplication so that we know without a doubt, we know that you know what you're doing. Okay, so moving along here. That's another way you could have broken it down. You could have did the 10 times 10 times 10, and that's what I said orally. So that's one way. But the way I did it was just the times 1,000. So those are the 2 different equations right up there. Alright, so now we're going to repeat the process with 4. So we have 4 ones right here. Just one group of 4 ones. And I guess it wants us to time it by 1,000, so I'm going to go back. Bring that birdie back. Okay, so we're going to do it by 1,000. This time we'll do the 10 times the 10 so that you can see it both ways, step by step. So my equation, I'll put it up here, is 4 ones times 10 times. Wish I had better control over this writing. Okay, times 10 times, this is just disastrous. Okay, 10 equals, okay, so 4 times 10 times 10 times 10. So you're going to move it again. Okay, so 1, 2, 3, 4. Whoop. And move it again, times 10. 1, 2, 3, 4. So we have 4 thousandths. Okay, another way we could express this, we could do 4 times 1,000. Okay? And both of us gives us 4 thousandths. Alright, moving on. So now we have 15 times 10. So if I put 1 here, and 5 1, so 1, oops. Erase that. And try that again. So 1, 2, 3, 4, 5. And we're going to multiply it by 10. So I'm going to take this 110 and multiply it by 10 here. And I'm going to do the same with my one group of 5 ones. Multiply it by 10. So that's 100. And 1, 2, 3, 4, 5. So that's 150. And there's nothing here. So 150. All right, moving on. And that's just a neater version of it. Alright, so what is 110 5 ones times 10? Well, we just went over that. We said it was 100 and, or is that what it is? Yeah, we did that. So 150. So we're not going to do that again. So I think they were just trying to show you a different way that you can express this. So in the previous slide, we did 15 times 10. And this one we're saying we're kind of like decomposing, which we already did on the place value chart, and say 110 times 5 ones. So 110 110 5 ones times 10. So there you go. Okay. Moving on to the next one. Alright, so now repeat the process using 22 times 100. So, remembering that each place value increases when you go to the left by 10. So, if I'm going to move at 100, I have to do 10 and then 100 over here. So, here we go. I'm going to show my multiplication, 100. And that will give me 1, 2, 3, 4, 5. Okay, and then over here, the same thing. Move it over 10, 100. So, move it there. This one group of 2 ones times 100. And I'll give us 200s. So now I have 5,000. Oops. Where did I get all these? Oh gosh, I'm just making up stuff in my head. So it should only be 2. Sorry. So, so 2,200. Supposed to be a comma. So that's what we have. 2,200. So next one we have 4 times 20. So we can decompose this. You will have to do this on your problem set. So what does that mean? So basically, let me go to my pen and use the arrow and show you how I would decompose this number. So I would break apart the 2 and the 10 here, and I would just do 4 times 2 times 10. Okay, so you will have to know how to do that on your problem set. So I'm just going ahead and doing it now, even though that will probably be the easier way, but it's okay. Just because it's less steps. So let me get my highlighter back. So we'll start with our 4 ones. So 1, 2, 3, 4, and then we're going to times it by 2, right? So that means I'm going to have 2 groups of 4. So 1, 2, 3, 4. So now I have a total of 8. Okay, so I have 8 here, and I'm going to times it by 10, and then that will give me 1, 2, 3, 4. 1, 2, 3, 4. So 8 tenths. That's it. Okay. And that's exactly what we have right there. So when multiplying with multiples of 10, you can decompose a factor to help you solve. This is an example. We express 4 times 20 as 4 times 2 times 10. And that's basically what I just explained on the previous slide. So with your partner, I will be your partner again, solve 6 times 400 using the simplifying strategy. So we're going to go ahead and decompose this. Let me get my pen out. Decompose this, and this will be 6 times 4 times 100. Alright, if you want to pause the video and see if you can get it, since you are supposed to do this on your own, go ahead and do that now. So 1, 2, 3, 4, 5, 6. And then how many groups of 6 are we going to have? 4. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So now we have a total of 24 here. And we're going to multiply it by 100. So that's one place value. That'll be 10. And then that'll be 100. So all the way over here. Times 10. And write it up here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we have our 4 groups of 6. So the problem here is that we have more than 10 here. Anytime you have 10, you got to regroup over. So we're going to go ahead and do that now using our pen. So we have 6 here. And we're going to add 4. Alright, and then we have 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so then that will give us, we regroup this over here. Okay, so 2,000, and how many are left? 1, 2, 3, 4. 400. 2,400, and we're done. Now, if it asks you how many hundreds you you would say 24 hundreds. But if it was asking you to write it in standard form, where you need to regroup it over, then you would say I have 2,400. Okay? Alright, next, moving along. So, with your partner, and again, I'll be your partner, solve 4 times 500 using the simplifying strategy. So hopefully this is becoming easier the more we're doing it. So we're going to do 4 times 5 times 100. Okay, so here we go. I'm going to switch back to my highlighter over here. So we have 1, 2, let me space this out a little bit. Okay, so 1, 2, 3, 4, and we're going to have 5 groups of 4. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Alright, so now we're going to times it by 100. So I'm going to take my group here of 21s and times it by 10 twice, so that will give me 100. Alright, and I'm going to move it over here, so here we go. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Alright, so we moved our 20 over here. Again, our problem that we have here is that we have, actually let me erase that. Let me make it less messy. Okay. Our problem that we have more than 10. So here we go. So we have 4, 8. Then we're going to add it over here. Regroup it. So we got 10 hundreds here over 1,000. What in the world did I just do? Okay. We have 1,000. How many left over? 1, 2, 3, 4, 5, 6. Okay, so now if it was asking us how many hundreds do we have after we did this, you would say I have, let me see, did I do 5 groups? 1, 2, 3, 4. Only did, I knew something wasn't right. I was looking at it like something's not right. Okay. So let me fix that. Okay, so get my pen back out. Alright, so do I have 5 here? 1, 2, 3, 4, 5. Yeah, I did. Okay, so now that looks better. So let's see, we got another group of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bring that over here. So now, come on, get that eraser. Okay, so 2,000. Now that looks better. It's like, what? Alright, so if it was asking us how many hundreds we would have, we would say we have 20 hundreds, or you would say 2,000. So just pay attention to see what they're asking you in the question. Problem said, yay! So, I believe with this one, let me keep going. I forget which one we need to do. Okay, so it says, what is the difference between saying 10 more and 10 times as many? So if I just say 10 more and I have 2, okay. So 10 more, what math operation would that be? Would that be adding, subtracting, multiplying? So hopefully it said adding. So that'll give you 12. Now if I said I have 2 times, or 10 times as many as 2, then that will be 2 times 10. And that will give me 20. So that's the difference in that. What is another expression that has the same value as 10 times 800 and 1,000 times 8? So we could do 80 times 100. And that will give us 8,000. So think about the problems you solved during the lesson and the problems you solved in the problem set, which you haven't done yet. When does the number of zeros in the factor not equal the numbers of zeros in the product? So the only thing I can think of is right here. Boom. Oh my goodness. Supposedly I was going to do that all flawlessly. Okay, so if I were to do like 20 times 0, that will definitely equal 0, because anything times 0 is 0. Because if you did 20 times 10, well, that would just give you 200. And then if you did 20 times 100, that will give you 2,000. So looking at our products here, and then our factors here, we have in our factor, one factor we have 1 0, the second factor we have another 0, and then we have 2 zeros here. And then here we have 1 0 in our first factor, and our second factor we have 2, then we came with a total of 3 zeros in our product. So only right here where you do 20 times 0 or any number times 0, then it's not going to equal the same amount of the zeros in here. So yeah, that's my answer. So moving on. For problem 4, you have 12 times 10 equals 120. Discuss with your partner whether or not this equation is true. 12 times 10 equals 3 times 40. Okay, I think this is problem 7, and I think that was an error there. But we're going to go over both. So times problem 4 and problem 7. And then it says, how did the application problem connect to today's lesson? Well, in the application problem, we had the Samantha, I believe her name was, and she was earning $3 for allowance a week, and then $30 for her babysitting, and then it wanted to know how much would she make after 4 weeks. So it's just showing how you're increasing that amount. So we had the 33 times the 4, and so we did that 4 times, or 33 added 4 times, or multiplied by 4, and we came up with, I can't even remember what it was, 132 or something like that. I don't know. And so yeah, so that was that. And that's what our lesson was about, taking numbers, and you can either decompose it, keep it together, and increasing that number, but by tens or 100 or 1,000. Okay, so let's go ahead and jump to our problem set. So here we go, and it says we're going to do 4 and 7. So I'm going to go ahead and get my pen here. Yep, I got it. Alright, so draw. Ooh, see, this one has a lot more colors. I'm going to do pink. So 12 times 10, that will give you 120. Alright, if we were to show this here, we would do 1, and then 1, 2, and then we'll times it by 10. So that'll be 100 there, and then times it by 10. And that will be 210, so that'll be 120. So, and that's what we're going to put here, 120. So that's the answer to that. Alright, now going to number 7. I wonder if that's the highlighter. Okay. So we'll try to be as neat as possible. So number 7 is 3 times 40. And then they decompose the 40 here. So it's 3 times 4. And then we need to do the other part of the 40, which would be 10. So now we're going to multiply these two numbers together, which would be 12, which that's what they put here. And then we're going to do 12 times 10. So 12 times 10 is 120. Oh, and the debrief was saying, are these problems the same? Well, they come out to the same product, that is for sure. So yes, it's another way that you can write it to get the same product. Okay, so that's how you're going to do these problems. If you need any help, remember we're available. Just contact me between 1 and 2, or sorry, 12 and 1, and Mrs. Allen's 1 to 2. So yeah, all right. Well, take care. See you again very soon.